Hello class, this is Mr. Lehman. I want to talk to you about Weather Lesson 10, Boyle's Law. Boyle's Law, we see a relationship. It's one of my favorite lessons. A lot of cool demos we did in class with the vacuum pump and the syringes. So we saw that if the pressure of on a gas goes up, then the volume will go down. If the pressure, air pressure goes down, then the volume of the gas will get bigger. And so we can come up with the equation based on this inverse relationship. If one doubles, the other will be cut in half. And so the initial pressure times the initial volume is going to be equal to the final pressure times the final volume. So here's the formula for Boyle's Law. Inverse relationship, one goes up, the other goes down by a constant amount. Let's take a look at two applications of this. We saw syringes in class. And so assuming we're at sea level, we'll say the pressure starting out in our syringe is 1 atmosphere of pressure. So you have gas molecules inside here. And if we take this and we push down on a plunger, and let's say we cut the volume in half, so if we push down on the plunger, instead of the gas taking up 50 milliliters of space, it now takes up 25 milliliters of space. Let me make some changes here. All the gas particles that were up here, all the gas particles that were up there are going to be forced into a tinier space. And so if they're forced into a tinier space, there's going to be more collisions, right? Just like if we had more students in the classroom, or we made the classroom half the size and I asked you to walk around, the molecules are going to be twice as close together. And so if they're twice as close together, there are going to be twice as many collisions. And if there's twice as many collisions, there's going to be twice the pressure. And so we get 2 atmospheres of pressure. Alright. If we take a look at a vacuum pump is hooked up to a motor. We put a balloon inside the vacuum pump. Let's say the balloon has a size of 3 liters. We start sucking the air out using the vacuum pump. More and more gets sucked out. If there's less and less air molecules inside, there's going to be fewer collisions, fewer atoms or gas molecules colliding, pushing that balloon in. And so as there's fewer and fewer molecules, the balloon will start to expand because there's less collisions pushing in on it. And so the air molecules inside the balloon will push out more. And so if our balloon starts out at 3 liters, if it triples in size, it ends up at 9 liters. We know our starting pressure must have been 1 atmosphere because we're close to sea level. If our balloon's 3 times bigger, that's telling us that the pressure has to be 3 times less. So in order for our balloon to get 3 times bigger, the pressure has to be 3 times less. Alright, so let's do a question here. If you have a gas that takes up 50 milliliters of space in a syringe, and the starting pressure is 1 atmosphere, if you want to increase the pressure to 5 atmospheres, what's the second volume? What's the final volume going to be? So once again, we start out, a gas is taking up 50 milliliters of space in a syringe, and the pressure starting out is 1 atmosphere. If we want to increase the pressure to 5 atmospheres, what will we have to do to the gas? Will we have to make it bigger or smaller? We established Boyle's Law, there is an inverse relationship. So if we're increasing the pressure by a factor of 5, our volume is going to decrease by a factor of 5. And so this one, we see that the volume, the gas particles must be 5 times closer to have 5 times more pressure, 5 times more collisions. And so the final volume must be 10 milliliters. We could also plug those numbers into it. They're not nice, easy numbers like this. We could plug the numbers into our formula and solve. So I hope this helped. Have a great day.